Hello everyone, welcome back again. My name is Jesse, and in this wonderful and exciting tutorial, we're trying to do a very interesting test classification problem, which is going to be emotion detection of test, right? So it's an emotion classification of test. So in case you want to read more, you can just go to papers with code, and then you can just get a lot of projects that people have done together with the code on different topics, right? So this is just for emotion classification. So you can just get some of the data set and then some of the papers and then read it. So let's go back to what we'll be doing. So in this our simple tutorial, we'll be trying to see how to do test classification, right? But this type of test classification is that you're trying to detect the various emotions within a particular test, right? It's similar to sentiment analysis, but sentiment analysis is trying to tell us the sentiment, whether it is positive, negative, or neutral. But emotion detection is you're trying to tell the emotion of the test, right? Which is similar. So let's see what we're doing. So this is where we got our data set from, credit to these places where we got the data set from. And then you can also get the data set from here, right? There are a lot of data sets you can use, but you'll be using scikit-learn, right? Not deep learning. So let's see what we're doing. So we're loading our packages. The package we're using is importing pandas, as we always do, as PD, and then we may import numpy, right, to help us with our reshaping, right, as np. And then we need to load our database packages to do some visualizations, which is going to be, in our first case, we'll be using matplotlib. So import matplotlib.py plot as plt. Then we also import seaborn to help us do some plots. These are the main plotting libraries, right? You can also be working with test cleaning packages to help us clean our test. So we're using neat test, so import neat test.functions as nfs, right? So these are the packages that you'll be using. So let's move on and see what you'll be doing. So first of all, we will load our data set. Let me make it bigger so that I can see. We're going to load our data set, right? So the data set is going to be from here. So pd.read underscore csv, and then going to load in our data set. So I'll go into my data set folder, which is my data folder here, and then inside my data folder I have my data set here, right, which is this emotion data set, right? So that's what you'll be trying to load, right? So I'll just go back again, then emotion dataset.csv. So that is the data set. And then one thing about this data set, that I have combined a lot of data set together from those that I got from here, and then to build this particular one. But you can keep on adding more data sets as you wish, right? So the power is in your hand. So let's move on and see what we're doing. So this is the basic idea behind emotion classification. So given a test, we want to classify it as neutral or no emotion or several other emotions, right? So that is the basic understanding. So I'll come back here and then we will just work on it. So let's preview our data set. So preview it. So df.head, you're going to it's just having two columns. It's having the emotion column, right, which is having different types of emotions, and then the test, right? So let's see the shape of this data set. So df.shape, which is not a lot. It's not a lot. It's like about 34,000 data points. And then we can also check for the data types, and all of them are, these are basic stuff. So let's see whether there are missing values there. Yeah, are there missing values within our data set? We can also check for missing values. So df.isNull.sum. So this is going to sum the entire stuff. So there are no missing data points, right? There are no missing values. Now what we have to do is that we have to make sure that we get the value count of the emotions. So let's get the value count of the emotions. So let's check it out. So df, right, and I'll just go to the emotions column, emotion, and then I'll just go straight away with what? Value count. So this is going to give us the value count of the emotions, and you can see from our data set that we have joy being the highest, sadness, fear, anger, surprise, neutral, disgust, sad, happy, shame, right? So these are the emotions that we have. We can of course add more data set and then make it more robust, right? So let's plot it. It's always advisable to make a plot of your value count. So just simple, just go dot plot. The kind is going to be bar. So if I plot this simple stuff, you can see it here, right? You can see from here that we have the joy, sadness, fear, anger, surprise, right? So joy is more than the rest. We can also use a different plot. So let's plot using Seaborn to plot. It's going to be like this. So sns.count plot, and this is the new way we can plot with Seaborn. If I go straight away with this is the old format. If I go with emotions, right, it's going to plot it perfectly for us, but it's going to give us a deprecation warning, right? So the plot came perfectly well, which is very cool, very nice, right? But we can make it bigger. So the newest way of plotting, this is the old method. So let's call this one as old method, right? That's why it's giving us this particular one. So the new method of plotting is going to be this option. So sns.count plot, right? And then we are going to specify our value, which is x. So the x is going to be our column that we want to plot emotion. Then this is going to be our data. The data is going to be the entire data set, right? So that is how to plot it. So this is why it's specified it here. So passing the following variables x, right? The keyword is x. So whatever you wanted to plot here now is going to be x, and your data is going to be your data set. That is a new format of plotting, right? So this is going to be new method, right? So let's plot it, and it's still going to work without giving us an error. We can also make this plot bigger and beautiful by just going plot.figure size, right? Fig size, which is going to be, let's say 2010, right? And then from here I can just go plot.show. So if I plot it now, it's going to plot it in a bigger format for us, with everything clear. So you can see from our data set that the highest of our data set is joy. So there is a lot of joy within it. So that means that this our data set is having how many? 1 2 3 4 5 6 7 8 9 10, right? Having 10 different labels. So it is a multi-labeled classification, right? Oh yeah, multi-class classification. And then it is imbalanced. So there are several ways you can do that. We can actually omit all of these things, 1 2 3 4, right? And then keep the bigger ones, right? So 1 2 3 4 5 6 to make our model more performant. Or we can include all of these things, and it's going to affect it. So this is imbalanced because some of them are very small. This is so small, right? But you can just keep these 4 or these 5, right, as you wish. But let's use all of them for now. Although the model, our prediction at the end is going to be very low. That is accuracy. So let's check it out. Now we have gotten our values, we have gotten our value count. What are the other things we can also do? So let's see some basic stuff you can also do. So it's going to be our EDA. Some other stuff we can also do, some other exploration we can do, right? So we can also check for, can do sentiment analysis on the entire stuff, right? And then we can also do keyword extraction. So the keyword extraction here we're trying to do is that we're trying to find all the keywords, right, for each emotion, right? This can be useful to help you understand why a particular prediction gave you that particular prediction was given, right, because of the keywords. So this is another thing we can also do. So in doing that case, we can also use a word cloud to help us see the most commonest word for a particular sentiment, right, or particular emotion. So let's check it out. So this is what we'll be trying to do. So first of all, we work with sentiment analysis, then we work with keyword extraction. So let's check it out. So I'll be using it's going to be sentiment analysis. So from test blob, you can also use spacey test blob. So from test blob, import what you have important is test blob, right? Let's add some other stuff to it. So this is going to be this. We also have to do some test cleaning, but let's do the sentiment analysis without the test cleaning first, then we work on the one. So test blob, import test blob, and then let's create a function which I'm going to call it a sentiment, or get sentiment rather. So get sentiment, that is the function we are giving, the name we are giving to the function. So get sentiment, then I'm going to pass in my test, right? Then this particular function is going to do two main things. We are going to create a blob from this particular test blob we have, and this blob is going to create a test blob class, right? We pass in our test. That's going to be the first thing. We're going to get our sentiment. The sentiment is going to be my blob dot sentiment dot polarity. You're only getting the polarity, not the subjectivity, just these ones. Then what you're going to create a simple function to group them for us. So it's going to be if the sentiment is less, right, or if it's, let's say, it's greater than 0, right? That means that it's positive. So our result is going to be positive, right? If it's greater than 0. Else, if the sentiment is less than what 0, that means that the result is negative. Anything less than 0 is negative. And then we're going to say that else, every other thing, we are going to call it as neutral, right? That is if it's 0. So that's something very simple. Now let's return our result. That's something very simple. So we have created a simple function to do our sentiment analysis. Now let's test our function. So it is always advisable that you test your function. So let's go with get sentiment. So let's call that coding. I love coding. So let's check it out. So this is going to give us a positive sentiment. So that means that our function is working. So let's apply this simple function on our entire data set. So we're going to create another place called sentiment, right? Then I'm going to apply it on my test, right? So I'm applying it on the test column, right? Then I'm going to say that dot apply. Now pass in my get sentiment. So this may take some time. So while this is running, it's going to take some time to analyze all these 34 different data points, right? So while it's running, we're trying to do some other stuff. So let's see what we'll be doing next. So later we'll be comparing them together to see how many percentage of our neutral, joy, sadness, fear, surprise, anger, that is negative or positive, right? Because something can be happy, but it can be negative. I don't know whether it's possible like that. So let's see, it's running. It takes some time for it to run. Perfect, so that's finished. Now let's check it out. So if I go back and I check out my sentiment, so let's check it out. So let's go with this. Let's check the entire stuff that you have done so far. So dot head, right? If I check it out, because we have our emotion, our test, and then our sentiment, right? So you can see from here that although this is neutral, right? Neutral, or this is joy, but according to our sentiment analysis, this is neutral. This is sadness. The emotion here is sadness, but it is negative, right? So let's compare and see. We'll be comparing our emotion and our sentiment to see how many percentage of our emotions are neutral, negative, and then positive. So let's see how to do that. So there are two main methods. The first one is, let's check, let's compare our emotion versus our sentiment, right? So let's see how to do that. So we can just use group by. So df dot group by. So I want to group the entire stuff, right? I want to group the entire stuff by the emotion and then by the sentiment. Then I want to get their size. If you run it like that, it's going to group the entire stuff and give us the comparison. So if you check the anger, this is the percentage of negative, neutral, positive, right? We take the discuss, the same thing, right? So you can see different results. So how do we plot this one? This is good, but one of the ways of doing this is you have to plot it. So let's see the first way we can plot this one out. So this is going to be our first method. So this is using behind the scenes using matplotlib, right? So if I go with this, I just go with dot plot. The kind is go to bar. It's automatically going to plot it behind the scene and give us our result, right? So hopefully it's able to plot without it becoming small. You can see from here that has given us our plot, right? Which is very cool, right? But this is good, yeah, but sometimes it is good, yeah, but it can be very confusing. So let's use a different plot. So using Seaborn to help us with that. So this is going to be using Seaborn. So Seaborn has two functions. It has sns.factor plot, right, which has been deprecated. We also have s.cut plot, right? So just as we had a count plot, right, which counts the entire column supplied and give you your result. We also have cut plot, right? So categorical plot is going to check the entire data set and group and count them per the categories. The same as the factor plot, right? Anyhow, it's going to be. So that is what we're trying to use. So we're using either cut plot or factor plot. All of them is going to work. So it's going to be SNS dot factor plot, right? So you just try the same thing. Then I'll specify my S. So the S is going to be, you can give the particular stuff that you want it to be. So it can be sentiment, it can be emotions, anyhow you want it to be. So let's go with emotion. So I want my X to be emotion, and then we specify the hue. The hue is going to be the color that you want to use. So in this case, we go with sentiment. Then you specify the kind of stuff you want to do. So the kind, what do I want to do? I want you to count them. That's what I want to do, right? So I want you to count them. So let's give the data. The data set is going to be my df. The kind, you can also specify the size and the hue and aspect ratio. So size, right? So you can just specify the size and then the aspect ratio. So that now it's giving us this deprecation error, telling us we should use cut plot, right? So it's going to give us a very nice plot, as you can see, and this is better, right? I feel this is far better than this one, right? This is too junk together. This is better, right? So you can see the neutral. We have the blue being neutral. We have the what's the name? For these are just for neutral. So then the percentage of neutral, negative, and then positive within neutral. For the joy, you can see that there is more positive sentiment within joy classification, right? Or the joy group. You also can see that for the sadness, right, there is a lot of negative, of course. And then for the fear, there is a combination of positive and then neutral, right? So this is very nice. This is a very cool plot. So this is one of the ways of plotting it, right? Since it's giving us a deprecation warning, we can plot it this way. So let's try another plot. It's going to be another way we can plot it using the cut plot, right? Categorical plot, not the factor plot. All you have to do is just change it from cut, and you can just plot it. It's going to work perfectly for us. Okay, so the size has been deprecated, so we can just take off the size because it's no more needed, and it's still going to work anyway, right? So there's another way we can also plot it, right? Very nice. So either you use the factor plot, right, which is this, or you can just use this one. It's still giving us same thing, right? Very cool, very nice. So that is some basic insights I've gotten from it. So we are done with the sentiment analysis part. Now let's move on from here to doing the keyword extraction, right? So this is going to be our keyword extraction. But before we do the keyword extraction, in order for us not to have a lot of stop words, we will be doing some text cleaning. So this is going to be our text cleaning. So the text cleaning aspect is that we will be trying to remove noise. So the noise, when it comes to NLP or text processing, can be stop words, right? Or functors or function words. Most stop words are function words. Then we also have can be special characters. We can also have, let's say, punctuations, right? So, and then it can be emojis for nowadays, and all of these things. So all of these things these are things we are supposed to clean from our test, right? So we really need tests to help us with that. So in case you have not watched the video on neat test, you can check it out. So let's check neat test. So if I go with DRL NFS, so this is neat test. So neat test gives you a lot of things out of the box to help you use for cleaning your test, right? So you can extract stuff, different patterns. You can also fix contractions. You can remove barcodes, BTC, currency, dates, emojis, hashtags, punctuations, stop words, all of these things. So be using this one, stop words, and then punctuations, right? And you can also, let's use just two for now. So let's see what we'll be doing. So I'll just go back to my test, so df, and then this is going to be my test that we are working on, right? So I want to, you can see from here we have some mentions or hashtags. So mentions here, we have some special characters here, and then we have some other stuff. So in case I want to remove all of them, I can just go with dot apply. Then I just pass in my functions nfs dot remove stop words to remove all the stop words within our test. So this is going to be df dot, let's call it as clean test, right? So it's going to remove all the stop words. Then you're going to see that's very fast there because it's using regular expression behind the scene. So if I go back again, and then let's try again to clean. We also want to remove not just stop words, we also want to remove punctuations. So remove punctuations, right? It's going to remove all punctuations from our test. Then finally you can also remove handlers, right? All these handles from it. So remove user handles. Right, So we could have run this one first. We can run this one first. Most of the time I prefer you remove the handles first before you remove the punctuations. So let's remove the user handles, and then now we can remove the punctuations. So if I go back again and I check it out, so df, and I check it out as I say my test, and then my clean test. Right, so I check it out. You can see from here that we have these things here, right? So that just clean it, right? So the stopwares have been removed, and then the user handle here is gone, right? And then some of these special characters, yeah, we can also remove all of these things in case you want, right? You can just remove the hashtags if you want, right? Because some of them are tweet, so you can actually add them, but that is going to be your own. Now let's move on from here to do some keyword extraction, right? So this is what we're using for our machine learning activity. So to do the keyword extraction, we're trying to extract the most commonest word. So we are trying to extract most commonest words per a particular class, right, of emotion. That's what we're trying to do. So let's check it out. So it's going to be very simple. Let's create a function. So from collections, import counter, using counter to help us with our stuff, and then we create a simple function to help us get our keywords. So def, I'll call it as I say extract keywords, right? And I'll pass in my test. And if I pass my test, I'm going to be using counter to help us get all of these things. Right, perfect. Since we have already cleaned the word, we can just go straight away and then work on our tokens. So it's going to be tokens, right? Then it's going to be whatever word that is coming from. So let's go token for token in text dot split, right? Just splitting whatever text that is being supplied. Then we're going to use counter. So let's call this most common tokens, which in this case is going to be my counter. I pass in my tokens because that's what we do most of the time. Then dot most common. So let's pass in a number here, a variable called number or a parameter called number. So let's give it as, let's say we can give it as 30 or 50. Let's make it 50, right, by default. Then we are going to return this one as a dictionary. So we have to return this entire stuff as a dictionary to make it better. So return this entire stuff as a dictionary. So most common tokens, right? Okay, so that is how to do that. Now we have gotten our function to extract our stuff. We also have to get all the emotions. So we have to make sure that we get all of them per emotion, right? So what I can do is that I can just go with this. If I go, let's list all the emotions that we have. So you can actually use a function. So let's say emotion list or emotion list. It's going to be my df going to my emotion, not my emotion, but the emotion for the dataset dot unique. Right, then to list. Right, so you're going to get it as a list, and then we can actually loop through them and get them one after the other. So emotion list, right? So this is going to give us neutral, joy, all of these things, right? We can actually from here we can now pass it here and then group them per what we want, right? So we want to get the joy, get all the part of the data that is having joy. So df, so this is going to give us only the part with joy. So it's supposed to be emotion, not emotions. So these are only places with joy, right? And what we need is that we need the clean test option. So I'll just go back again and then pick the clean test. Right, so it's going to pick only the clean test for us. Perfect. So we want to combine this entire stuff into a list and into a list of tokens so that we can be able to pass into our function. So now I can just go back again and equate this one to, let's go as my joy list, right? It's a list. So to convert the entire stuff to list, right? So this is going to be in the format of a list. Now in case I want to get it as tokens, so joy tokens, right? Or let's go as joy document. Joy document. So it's going to be joy docs, right, for joy document. Then I'm going to say that put the entire stuff in a format of a document, a whole corpus, one corpus, right? So this is going to be .join. I'm going to go into my joy list. So if I check this one out, it's going to be a whole sentence, like a paragraph, like of all the various words that we have, right, together as one bulk stuff. The reason we are doing this is that we want to be able to get the keywords, we want to get the tokens, and we also want to use word cloud to be able to plot them out, right? That is why we are doing this one. Perfect. So let's go back again now, and let's extract the keywords. So this is going to be extract our keywords. So in extracting the keywords, it's going to be very simple. I can just go straight away with this, my extract keywords. I pass in my joy docs. So I can come back again and call this one as my keywords joy, right? Giving us an error here. So let's check the error. So name token is not defined, so you have to go back into our for token. Yeah, so we made a mistake. Yeah. So now let's run it again. Perfect. So if I go back and I check for the keywords for this, for joy, we are having 50 now, right? This is 50. So day, amp, time, blah 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 blah, right? Very cool. So these are the words there, right? I thought I saw God. Wow, interesting. I have friends, feelings. Okay, very cool. So these are the top 50 keywords within our test, right? Very simple. Now, in case I want to plot this entire stuff, I can actually plot it out. So the simplest way of plotting this one is that we can just use a data frame to plot it out. So let's check it out. So let's create a function to help us plot. So df, let's call it as my define a function called plot most common words, right? This function is going to take my dictionary that is being supplied, right? Then what does it do? It's going to convert the entire dictionary into a data frame. So let's go to data frame 01, which in this case is going to be my pd.data frame, and this is going to take my keywords. So it's going to take my dictionary. I'm going to unpack the entire stuff. I'm going to get all the items of it. Then I'll specify a column. So the column is going to take my token and then the count. So as you can see from here, we have the token itself and then the count, right? So we want to plot it. So this is going to be a very simple way. Then after getting it as a data frame, we can just plot it with Seaborn, right? That is going to be better. So sns.bar_plot. And I'll just go back again. S is going to be, for the S, you're going to specify the token. And then for the Y, I'm going to specify the count. And then the data is going to be my df01, right? Then plt.show. So this is going to plot it perfectly for us, but let's add some figure size to it. So figure size. In case you have any question or contribution, you can let me know. And in case my audio is so low, you can also let me know, right? That is something very simple. And also let's rotate. So plt.s text rotation is go to 45. So the reason we are doing this one is to make it very nice for us to see. So we have gotten our joy keywords, right? Which is in the format of a dictionary. Perfect. So in case I want to plot it, so plot most common words for my joy keywords. Now this is the dictionary, so it's going to understand it and then unpack it and give us our result. Take some time for it to run. Voila, right? That is giving us a very nice plot. You can see that day, amp, time, imp, I am, right? These are all the most commonest words. Then we have some other stuff there. So one thing we can also do, if you want, you can actually remove 3-letter words. But I think joy, if you are going to remove 3-letter words, joy is also going to be removed here. So that is something very simple. So you can actually apply this same function that we did, this code here, right, for all the various, for all of these things, for the sadness, for the surprise, for the shame, for the neutral, and all of these things. So let's check for surprise. or let's check for surprise. So it's going to be the same thing that we have done here. So I've copied the entire stuff and we can now check it out. Perfect, so I've gotten it all. So in case I want to plot it, I'll just use the same function I did here, this same plot, this same function to plot for the surprise, right? So this, you can actually even add the title here, or let's say you can add a figure title. So you can just do it at plot.title, and the title is going to be you can just pick any title, right? Something very simple. So plot of dot format, so at least it gives a particular form. So let's say emotion name, something like that. Then I'm going to create another option here called emotion name, right? So this is a new plot. Now in case I want to plot, I can just come back again, the same plot, specify the emotion name, which is going to be joy. So if I run it, it's going to give us a plot of emotion name, right? So this is another way to make it beautiful and then more useful, right? Plot of joy, plot of keywords of joy, or whatever you call it, right? Plot of joy, most common keywords, right? So this is a better format. So this, if I run it again, so plot of joy, most common keywords. Then you can also apply the same function on this one. So perfect, right? So plot of joy, most common keywords. You can give it a better name if you want. Then we can try the same thing from here to for the surprise. Then I can just go back and say that this is going to be surprise. This is here. So it's going to print and give us our result, right? So you can apply this thing to all of them. Now we are done with our simple plots. Very cool, right? Now let's do another plot we can also do, which is going to be word cloud. So just going to be from word cloud, import the word cloud class. Then we can just create a simple function. The reason I'm doing most of the thing in functions is to make it easy. So def plot word cloud, then this is going to take the docs, right? Document, then it's going to be my word cloud. The reason I'm using my word cloud is I don't want you to confuse it with this, right? That is why I'm putting my word cloud here. Then this is going to take the word cloud class, but it's a function that takes generate. Then I pass in the text docs, right? Then I have to do the other meaning, right? So let's work on it. So let's plot.figure. We can just give it a figure size, so as we always do. So 2010. Just change it out. Then plot.im show. Then this is going to take my word cloud and then the interpolation. So my word cloud. Then the interpolation. Let's go to bilinear, right? I don't know whether the spelling is correct. Then plot.show. So this is how to plot the entire plot, right? You have to make sure that you take off the others. So let's take off the others. So plot.axis. So this axis of, I'll explain it for you to see. Perfect. So we are just creating a word cloud from the document that is being supplied. Then we are going to print it out, right? So to be able to get, we need the documents, not just tokens. So that is why we are calling it as docs. It's going to be my plot word cloud. So this time we're just going to plot the joy docs, right? So this joy docs, whilst it's plotting, it's giving us an error. Oh, we spelled it wrong. Generate. Perfect. Let's run it again. So the joy docs, as we saw, is this particular joy docs. The one that's like a whole sentence or a whole paragraph, right? This is what we are trying to plot, right? It must be that one, not the tokens. Word cloud is automatically going to identify it for us. Voila. Oh, it has given us a very nice plot, right? So the most commonest words there: today joy day. Yes, today is a joyful day. Very nice. And then work and laugh. Wow. Christmas, school is joyful. Okay. Oh, there is great home. That is nice. So that is how to do the word cloud, right? So if I take this one off, you're going to see there's going to be others around it, right? So that is why we have that. We have the others is turned off. It's going to put a line with some numbers there. So it's taking some time for it to run. So you can actually apply this simple function on the remaining words, right? So that has given us these things here, right? But we don't want them. That's why we take the others off. That is the purpose of this one here, right? Perfect. So you can actually apply the same thing on the surprise docs. Let's try it out. I'll go back and try it on the surprise docs. And it's also going to work and give us our result. So after we are done with most of the exploration or test analysis of our particular corpus, right? So one of the things we need to do the test classification itself. So let's move on to our test classification. This is going to be our machine learning aspect. So machine learning. You can also use deep learning to help you with that. So machine learning. So this is going to be our machine learning part. And then the recommended algorithm, can use any of them, but you'll be using naive Bayes, which is very useful for test classification. You can also use logistic regression. You can also use KNN, decision tree, as much as you wish, right? You can use any of them. And then there's also some other stuff you can also do. Later on, maybe in the future, you try and compare this one. Compare with Spark NLP. So Spark NLP or NLE package. There's a package called NLE from John Snow's lab, right? Which is a very nice package that is having emotion classifier already within it, right? So you can also do that one later on in the future, maybe in the future, but not now. So let's build our model. So we'll be importing our machine learning packages. So we'll be importing these packages. So from sklearn dot, the first one is linear model. Let's import logistic regression. Then also from sklearn dot naive Bayes, we are going to be importing multinomial. How do we spell it? Right, perfect. So this is going to be our packages. Then also for our vectorization. So as we already know, most ML algorithms do not understand tests. They only understand numbers. So we have to vectorize them, convert the test into numbers. We have to build features from our test, right? So that case is going to be from sklearn dot feature extraction dot test extract the test. I want to import count vectorizer count. You can also use TF IDF anyhow you want it to be. So TF IDF, any of them is going to work. That's going to be for our vectorization. And then for our metrics, so from sklearn dot metrics, we'll be importing all of these things. We import accuracy, score. We also import confusion matrix. We also import classification report. All of these things are to help us evaluate our model and then plot confusion matrix. Right, perfect. Now one thing we also forgot is we have to make sure that we split our data set. And to do that, just go with from sklearn dot model selection, import train test split. You can use this train test split to help you with that, or you can also use pandas to split the data set. Anyhow you want it to be, it's still going to work, right? Perfect. So that is all. This is for the machine learning aspect. Now we need to be able to get into it to build features from our test, right? As we said, machine learning algorithms don't understand tests, they only understand numbers. So you have to build features from our test, right? That is the next activity we are supposed to do. So let's see how to do that. So it's going to be very simple. So let's call this my S features. I'm going to pick my clean test column, so clean test column. Then my Y labels going to be my emotion column. Right. So this is going to be what we'll be trying to vectorize. So if I check the S features now, I call it S features so that you know that the S is for the features, right, and the Y is for the labels. So we have to convert this one into vectors, right? So into numbers. So how do we do that? So we can use count vectorizer to help us with that before we split them. So let's create our vectorizer. So CV for count vectorizer, count vectorizer. You can just specify the other parameters, but let's make it very simple using the default. Then CV.fit transform, because this we can actually create a pipeline, right? I remember there's a whole video that we learned on creating pipelines to do all of these things. You can actually create a pipeline to work on it, but let's move on straight away with this, and maybe the other one we'll try another pipeline for that. So cv.fit transform, I'm going to pass in my features, right? So S features column. So this is going to vectorize it, vectorizer, fit and transform them. So in case I want to get all the features, that's created a sparse matrix, right? Space, that means there are spaces between them. And then in case you want to get the entire stuff at dense, you can also go that. So let's get the vectors. So one thing we forgot here is that when we are fitting, we just fitted it straight away. We need to fit it into a particular variable. So let's call this X, right? Let's run it again. I guess I want to get the features by name. I can just go with cv.get feature names. This is useful. This is useful in case I want to, it's a function. This is useful in case I want to use ELA5 to interpret all the various features, right? Which you'll be trying to see later on in the video. So these are all the features that are built, right? The feature names. Now, if I go back to the S itself, it is no more test. This is a sparse matrix in case I want to get the entire stuff to array. This is now going to convert the entire stuff to dense array, right? Or numpy array. Dense numpy array is numpy, right? So dense array to dense array. No, that is to dense array or to dense arrays. Yeah, so that is giving us I don't know, I've forgotten the name. Don't worry, you fix it. Yeah, it's giving us an error, right? The error is a memory error because they can't allocate this amount of cake for an array because my system is so small, right? The memory of my system is small, so that is why it's giving us this particular error, right? So let's move on, and now we have gotten our vectors. Perfect. So for us to be able to build our model, we have built our features from our test. In case I want to build a model, so let's split our data set first. So it's going to be my S train, and then my S test, then Y train, and then Y test. Then I want to train, test, split. This is going to pick in the particular value. It's going to take my S, right? Then my Y labels. Then I'm going to give the test size. So the test size, let's give it as 0.3, right? Then you can also specify the random state in any of these particular parameters. So let's go with the random state. So random state. So this random state means that if you run this same code, you're going to get the same values as I'm getting, right? That's the meaning of this. And you use this particular state of 42, you're also going to get the same shuffling. Perfect. Now let's build our model. So it's very simple. In building our model, this is going to be our model. We'll be using naive Bayes, and then we use logistic regression to help us see the result of our model, right? So let's call this NV for naive Bayes model, right? Which is going to be my multinomial MB. We are not putting in parameters, so NV model dot fit, and I'm going to pass in my S train and then my Y train. So we're just building our model, right? It's going to take some time. Finish. It's very fast. Now let's check for the accuracy of our model. So this is the first method. So just comparing it with the test score. So NV model dot score. I'm passing my S test and then my Y test, right? So this is going to give us our model. It's going to be very low. That's 52%, right? That is one of the ways. Now let's get our predictions. It's going to be, let's go to Y predict for naive Bayes, right? Which is in this case going to be very simple. It's going to be my model. So a naive Bayes model. We can call it NV, but anyhow you want it to be. Right, and I'm just going to specify that predict. What do I want you to predict? I want you to predict using my S test. Right, perfect. So if I go back and I check it out, right, giving us all of these particular stuff. So how do we evaluate this particular model, right? So we will first of all, before we evaluate the model, let's first of all make a single prediction to see whether our model is working, right? Single prediction. So we're making a very simple prediction, and this was how it was. Before we build our model, we had to first vectorize it, right? Our test. Then after that, we applied our model. So that is the steps, right? So in case you are building a pipeline, you can also use the same approach. So let's see how to do that. So I'm just going to go with my sample. So let's say my sample test, which in this is going to be in the format of an array, right? So let's say I am, or let's go just I love coding, right? So much, right? Something like that. So this, perfect, right? So in case I want to vectorize it, this in the format, make sure that it's always in an array or a list. And then in case I want to vectorize it, I can just use my count vectorizer to do the same thing. So it's going to be my vectorize test equals vect, anyhow you want it to be. Then my CV dot transform, I'm passing my sample test. Then I convert this one to an array. Right, it's very important at the origin version. So this is to an array, and now from here I can actually make my prediction. So let's apply the make prediction. So it's going to be my model. So my model was called nv.predict, and I'm passing my vector. So now it's going to tell me that it's giving us an error here. So let's fix it out. So nv is not defined. We call it as nv model. So perfect, give us joy. We call it as nv model here, nv model here, nv model here. So if I check it out, it's giving us a very nice prediction, which is joy, right? You can also check for the percentage of this, right? So that is for the prediction probability. That is the percentage for all of them, right? So what is the percentage and for giving this particular prediction, right? So how accurate is this prediction? What is the confidence score for this particular prediction, right? Why is it giving us joy? So in that case, I can just go with my nv.model.predict proba, and I'll pass in the same thing I passed. So now this is going to give you these numbers. Whoa, what are these numbers for, right? And you see that you can't actually you don't understand this particular number. So what does this one mean? So this is, we had 10 different labels. So to get all the classes for our model, right, it's going to be nv model.classes. So this is going to give you all the labels, right, that we had. Remember that one nice thing about using for text classification, most of the time, if it's like this, you ignore you don't vectorize the label, right? And this anger is the first one, disease is the second one, fear is the third one, happiness is this one, and then joy, right? So that explains why. So in case I want to get the maximum value here, I can just come back and get and just do np.max, passing this. This is the percentage, right? This 6.8 is referring to this one, right? That is why it gives us that particular prediction, right? So in case you want to get the prediction percentage for this, so this is the 8% sure that it is joy, right? So we can actually create a function to make it easy for us. So let's check it out. I'm going to create a function called predict emotions. Predict emotion of the test, right? So I'm going to pass in my test that I want to predict, and then I want to pass in the model. Then what does this particular stuff that's going to go with my vector? So we'll be using the same thing we did here. So I'll just copy this once here, just to save time. Copy this. Right, the same thing. So this is, let's go to sample test. So that it matches sample test, sample test, sample test. Then from here, I'll just, what again did we use? We applied this model on it, and then we applied the prediction probability. So we're going like this. Now what you are doing is I'm going to make our prediction using the model. So this is a sample test which we are going to vectorize, and then we are going to use a model to specify to make our prediction, and this is going to be my vector, right? Then I can also do the same thing. So model, so let's call it as, this is going to be the prediction, right? And I want to get the prediction probability, prediction proba, which is going to be the model dot predict proba, then my vector. Then what I want to do is that I want to build a dictionary so that it also shows not just the prediction and the probability, but also shows the percentage of each and every one of them. So let's add npa.max to get that particular percentage, right? So the percentage for that. Then let's go as my prediction percentage for all, right? For all of them. So I'm just going to create a dictionary, which is, I'm going to zip them together. Then I'm going to pick my, first of all, I'll pick my prediction, right? That is, now I'm going to pick, let's pick this one here. So what we do is that we're going to go with it this way. I'm going to pick the model specified, the model classes, right? Right, something very simple. So we can actually make this one simple. Instead of we making it like this and all of these things, we can just take off this, we get that particular value, then we pass that one here, right, to make it simple, to make it cleaner, right? So predict proba, right? Perfect. And now we can just return can actually do this one, right? So let's check this out. This 0 here means that you're getting it's going to come as an error. So let's try it on our test. So predict my emotions, right? I'll just pass in the same sample test that we had, right? Then I'll just go with the model. So let naive base model. Perfect. So that the prediction was joy, and then this one gave us, but this is not the best way. It's giving us an error here. So let's fix it with this option. It's going to be 0, right? Let's go back again. run it. Perfect. So joy was the prediction, and the anger, and then the percentage is 0.6. We can actually add this 0.6 also as part of it by making it like this. So let's make the function nicer. So I can just go straight away and do it like this. So print prediction, right? So the prediction is applied, and then the probability or the score right, something like that. So dot format, then this is going to pick my prediction, right? That's going to be the first one, so 0. Then the second one is going to be this particular one, the maximum value here. So you can just go np.max, or just go to normal max, but let's go with numpy.max. Then I'll go with my prediction prober, right? So this thing goes off anyhow you want it to be. You can actually return this one, but I want us to get the dictionary too. So let's apply it again. Now prediction is joy, the prediction score is 0.6%, right? And that is what is showing here. Very cool, right? Very nice. Now let's try something on something else. So predict the emotion. What are you? This must always be an array, so let's say something like, say, he hates running all day, right? And then let's use our model. So the model we are using is naive based model, so naive model, the one that we trained. Run it. Prediction is also joy, and this is giving us a very high percent. He hates running all day. I'm surprised this is joy. The reason it's given us this particular prediction is because joy was having the highest amount of values there, right? So we can also actually evaluate our model. So let's do some model evaluation. So this is going to be model evaluation. Then we'll see how to interpret our model. So model evaluation, right? How do we do that? So you can just use the simple classification report, right? You can just do the simple classification report. So we have already imported it to print classification report. Then this classification report is going to take my y test and then my y predict, can't spell predict, y predict for naive base, right? So this y predict for naive base is coming from here. If you remember, we created a function, this one here, right? And then the y test is coming from our train test split here. So this is it. So we are trying to compare it and then give us our classification report for all the 10 classes, right? Very cool. So this is a precision, the record, the F1 score, and the support. And then we can actually also do a confusion matrix, which is going to be the same thing. So confusion matrix, which is going to tell us the true positive and the true negative. This is going to take the same thing we did, y test and then y predict. You know, sometimes I confuse this one, right? I can change this one. You change it. Perfect. Wow. So what is this? See, these are the various. This is just 10 by 10 of all of the various labels and then their confusion matrix, right? And you can actually make it better by using the plot confusion matrix, which make it better. So it's going to be plot confusion. This is part of scikit-learn. Then this is going to take your model, so naive based model, and take your y and then your s test, right? So it's going to take your s test and then your y test. So what it's actually doing is that this s test, right, is what we use to get the prediction probability, which is this one, So it's going to also calculate it using your model. It's going to calculate this one for you, and it's going to compare it with your Y test. So it's the same thing above. Let's give us our plot, which is not a bad plot anyway, with all the various values, right? And you can see that this is how it is. So we have the anger, disgust, fear, happy, joy, neutral, and these are the values. So this is more better to me, right, than this one. So you have seen how to evaluate our model. Now let's see how to interpret our model. But before we move on to interpret our model, we can use Eli 5, you can use Lime to help us interpret the model. But let's save our model first before we go to interpret it. Right, so because we're using this one to do some other stuff maybe in the future, right? To build maybe a Streamlit app or a Flask app in the future. So we're using joblib to help us save our stuff. And I'm going to call something called my model file. It's going to be open a file, right? Right, model, let's call it as we can give it a particular name. So let's call it emotion classifier. Then the name of the model, NF model. Then the date is today is 16th. That is in case you are not 16th, today is 8th. If you are watching from the future, 8th April. I prefer to always name 2021.pickle so that I know when I created this particular model, right? That's going to be the first thing. So we're just going to create a particular class, right? So we must write it as byte. Perfect. Then I'm going to load in my stuff using joblib. So joblib.dump my naive base model into my model file. Then after I have finished everything, I want you to close that file, right? This is very important. Otherwise, you're going to, after you have serialized your model, you will not get your model, right? So it has saved it perfectly for us. If I check it, you can see that now it has saved it. If I go back here, you have our model saved, right? Perfect. So we have saved our model. Now let's move on and see how to interpret our model. But to interpret our model, this is going to be the last part of the stuff. Interpretation. So we can use Eli 5. We can use Lime, we can use Sharp to help us interpret our model, right? But one thing is that when you use naive base, you can't use Eli 5 to interpret it. So you need logistic regression or something. So let's create a pipeline. Then after creating a pipeline, we will try and see how to use that particular pipeline with our explanation, right? Anyhow you want it to be. Or we can just go straight away with our logistic regression model and see it. So let's first try it out. Regression model, right? So in that case, it's going to be something like this. So let's go as my LR model. This is just going to be very fast so that because the same thing, regression, right? And I'm going to pass in fit in my model, fit my S train, and then my Y train. To build the model very fast, it's going to do the same thing we did above, making the prediction and all of these things. So I can just come back again and apply the same fashion we did, right, on our test. So apply this thing to save us time. So take some time. Let's check for the accuracy before we move on. So that's going to be LR model dot score. I'm going to pass in my S test and then my Y test. So this is going to be used to help us get our accuracy. Then after getting our accuracy, we're going to be applying it on our test. We're going to make a simple prediction. So it's going to be the same thing we did, the same function we created, not this particular function. The function was predict emotion, so predict emotion. Then I'll pass in my sample test, the same sample test that we had. Then this time the model is going to be my LR model, right? So it's taking some time for it to run behind the scene. That is why it is slow. So that is all. Now whilst it's running, I'll be writing the code for the model interpretation. So model, it's very important that sometimes you, most of the time, not just evaluate your model but interpret, right? It's giving us an error here. This is the error is given to us because of the number of iterations, because it's too huge, but it's still going to work anyway. So if I go back and I check, it's going to be our 58%, which is like the same thing, right? 57%. And I can actually check it, right? We need more data. We need to make it more balanced. So this was the percentage, right? Which is quite higher than what we had here. Here was, what was the prediction? 68% with the naive base, and it was joy. But for the logistic regression, it was 70%, right? So that means that the logistic regression model is better. Now we can actually interpret this particular model using Eli 5. So interpret the model. So we're going to import Eli 5. Right, and then with the Eli 5, you can actually see the features for each and every one to show the weight for each class, right, or label. So in case I want to show the weights for each of them, you can also use Eli 5 to help us with that, which is very useful in interpreting your model. So I can just go back again, go with Eli 5, show weight, and I'm passing my model, which is going to be my LR model. And I specify that I want to get the top, let's say 20 rows. And as you can see, it has given us these values. Let me change it so that I can see what we have. Change it to the lighting. So by what you have done so far, you can see all the steps, right? It has taken a lot of time, but I hope you have learned some things from it. Oh, so the white thing is that nice. Anyway, we just move on. Now if I come down here, you can see that this is our weight, right? So for the anger, these are the top features. For the discards, these are the top features, but these are all numbers. These are all vectorized numbers. So in case I want to get it, I have to supply them. So how do we do that? You can just go back again to the same thing that we did. So I can just go back and get all the classes. Let's go to class names. So the class name is going to be my Y labels, right? This is my Y label. Then dot unique to get it as unique. Then let's convert it to a list, right? So this is going to be my class labels, right? So let's go as my class labels or class names, anyhow you call it. I think the correct name is names, right? Not L names, but names. Now what about the features? So the features is, we remember we have something like this. Get feature names, right? This is all the feature names. All these numbers you are seeing here, all these numbers, this is the feature names, right? So it's going to map them perfectly to it. So I'm going to call this one as my, if you can check, this is a lot of numbers, not just numbers, but every word there has been tokenized and then converted to features. So now I can just call this my feature names. So feature names is going to be this, right? Get feature names. Now in case I want to plot it, I can just go back again to Eli 5 dot show weight, right? Then I'll pass in my model. So my model is, this case I'm going to pass my logistic regression model because naive base will not work. Model, right? And then here I'm going to pass in my feature name. Feature names is going to feature names, and then the class name is going to be class, I hope it's names, right? So I run it again. Hopefully it's going to work perfectly. It's giving us an error because I missed some of them. So let's check it out. So just going to simple like this, question mark Eli 5 dot show weight. That is how to get the parameters. So we have the dot strings, and you can see that it's giving us all of this information. So the parameters is the estimator, which is the model, right? The top is the amount of features I want to see. It is called target names, right? So we have the target names, not class names. So that is what we have to call it. So this has to be named as target. Apologies for that. So target names, right? Now hopefully it's going to work. Voila. So this thing we had here, which was full of numbers and all of these things, with like 5 show weights, we can actually know that exasperation, indignation, resentful, all of these words, right, are for our neutral. Revolution, disgranted, revolted are for our joy. So these same words, if you check the joy top words, I'm sure you're going to get some of them, right? You're going to get some of them. That is how it understands it. So anytime it's making prediction, it's looking for these particular features to give it that particular result, right? Very, very cool and very nice. That is how to do simple text classification of test or emotion detection of test using machine learning, right? Using scikit-learn, Python, neatest, and then pandas, right? Very cool and very nice. So thank you for watching this long tutorial. In case you have any question or contribution, you can just put it in the comment section below. In case you also want to make prediction, you can use the pipeline option to do the same thing. So thank you. So let's recap. So to recap, all that we did was that we are trying to detect emotions from a test. This is different from sentiment analysis. And then we got a data from this place. We imported our main packages here once as usual. We got a data set which had 2 columns, emotion and test. We went on to do some basic activities like trying to do sentiment, getting the value count using 2 methods, trying to do sentiment analysis of our test, and then we compared our sentiment analysis with one another together with our test like this. Then later we did some test cleaning using neatest. We found the most commonest word. We did some word cloud, and then we did our machine learning as well as evaluation of our model and then interpretation of our model. So thank you for watching. See you another time. Stay blessed.